This poster summarises the metabolic pathways of the body and adaptations that take place during anorexia nervosa. The body metabolises lipids, carbohydrates, and proteins differently to produce and store energy and other products depending on the needs of the body at the time. Energy is produced in the form of adenosine triphosphate, or ATP, the body's energy currency. This is predominantly regulated by the hormones insulin and glucagon. Glucose is the preferred source of ATP, and blood glucose levels are carefully maintained through different pathways, depending on the length of time since food was last ingested. ATP is produced in large quantities through oxidative phosphorylation. Reduced coenzymes produced during metabolism provide electrons needed to produce ATP. Carbohydrates are the preferred source of glucose, and carbohydrate metabolism involves glycolysis, the breakdown of glucose, glycogenesis, the storage of excess glucose as glycogen, and glycogenolysis, the conversion of glycogen back to glucose. Lipids are metabolized during lipolysis into fatty acids and glycerol, producing large quantities of ATP. Fatty acid degradation involves beta oxidation to produce reduced coenzymes for oxidative phosphorylation. Excess lipids are stored as triacylglycerides through lipogenesis. Excess protein and carbohydrates are also stored as such. Protein metabolism produces glycogenic and ketogenic amino acids. These undergo transamination and oxidative deamination to produce non-essential amino acids or carbon skeletons, to produce glucose, fatty acids, ketone bodies, or citric acid cycle intermediates for ATP production. Metabolic adaptations take place during anorexia nervosa, or starvation, to maintain blood glucose levels. These include the metabolism of body proteins to produce glucose via gluconeogenesis. 30 to 50% of protein depletion can lead to death, so gluconeogenesis can't continue indefinitely. Fatty acid oxidation produces acetyl coenzyme A to enter the citric acid cycle, generating reduced coenzymes for oxidative phosphorylation. Ketone bodies are also generated from fatty acid oxidation. These provide an alternative fuel to glucose, which reduces the need for gluconeogenesis and further protein degradation. Ketone bodies can lead to ketosis if their concentration is too great, which can lead to health problems.